So, very good morning, students. So, welcome to IIT NEET Foundation Program or Focus C by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 7th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, that is second chapter, Kinematics. And today we are entering into the session number 3. So far we completed 2 sessions in understanding the basic terminology of kinematics. Means kinematics is first what we learn is, first we learn about what is motion. This is the basic part of the kinematics. So kinematics is a branch of physics, deals with the motion of a body without considering the cause of motion. So we learn about what is rest, what is motion, and what are the various types of motions. So many we have seen: translatory motion, rotatory motion, vibratory motion, oscillatory motion, circular motion, and all types also. After that, we discuss about some terms. When some terms would come across when body is in motion. When a body is moving, the body will have, it covers some distance and displacement. We discuss about both of these along with the differences, right? Then body will have speed or velocity. These two also we discussed in the last class, and these are the topics what we discussed. Then today we discuss about what is acceleration and negative acceleration, which is also called retardation, right? After discussing about what is acceleration, what is retardation, we have to move to the relationship. So what is the relationship among distance, speed, acceleration, velocity, time, and all? This relationship gives us some important formulas. Some important formulas which are basic formulas in physics, which are called equations of motion, right? So before that, let us start with the acceleration part. After knowing what is acceleration and we'll come to know what we'll discuss about the okay. So correct. So directly we'll go to acceleration. Okay. So acceleration, name itself clear. You know, every two-wheeler or four-wheeler or anything have accelerator. What is the acceleration? Increasing the speed. Increasing the speed from time to time is called acceleration. When you are traveling by two-wheelers, to increase the speed, what we'll do? We'll raise the accelerator, right side. As accelerator raises, the vehicle will increase the speed and go fast, which can be seen on the speedometer, right? Means what is happening here? The speed is changing. There is a change of velocity, change of speed. That is called acceleration. That is, so acceleration is nothing but rate of change of velocity. For example, formula A is equal to V minus U by T. The mathematical formula for acceleration. Suppose say body starts with U. U is the initial velocity, right? Body first starting with zero velocity. Suppose you have vehicle stand you removed, the velocity is zero only. Then its velocity increases to some time, final velocity. Increase the velocity. To change the velocity, take t seconds. Time is t seconds. So then the rate of change of velocity is called an acceleration. V minus U by T. So what is the first velocity? What is the last velocity? Divided by time. Time taken to come from 0 to some velocity. That is called rate of change of velocity, which is known as an acceleration. It is an important term for every moving body. So the changes in the velocity may occur in short or long time of intervals. Sometimes very quickly will change, sometimes we play slowly. To describe the velocity of an object changing during a given time interval, we know introduce new idea of acceleration. This idea depends on two concepts that we previously encountered: velocity and time. Especially, the motion of acceleration emerges when the change in the velocity is combined with the time during the change occurs. The meaning of average acceleration can be illustrated by considering the plane during the takeoff. Focus attention on the how plane velocity changes along the runway. See, so initially like this. So as runway moving on runway, the how the velocity changed from here to here. That is called acceleration. Change of velocity in fraction of seconds. It won't take much time. Aeroplane started slowly, and for runway to take the takeoff, it will acceleration. The velocity is increased like this. So from here to here, no way matching within fraction of seconds. Such a change in velocity is called our acceleration, mathematically given by, right, A is equal to V minus U by T. So when you move details, again we'll get some more examples for that. You can see during an elapsed interval, elapsed means time gap, starting to speed up. The velocity changes from 0 to V, V0 to V. V0 you can call it, you can call it as V0 to V. The change in the plane velocity is final velocity minus initial velocity, that is V minus V0. The average acceleration is defined as manners to provide the measure of how much velocity changes per time. That is average acceleration, average V2 minus V1 by T2 minus T1. Time is there means. Or we can write final velocity minus initial velocity by time taken. That is V minus V0 by T. Or V minus U by T we can write. Right? So that is the definition. So many examples are given how they are changing the speed. Starting some, again change the speed and speed up more. As they are speeding up, the gap between, here see, here speeding up, slowing down here. Slowing down slowly here. So acceleration can be either speeding up or slowing down. If it is slowing down, that is called the deceleration or retardation or negative acceleration. So many diagrams are given here, right? Okay. So acceleration is a vector quantity because it maintains specific direction. Same direction as change of velocity. Since velocity is vector, it can be changed either magnitude or in direction. Acceleration therefore changes in either speed or direction or both. Keep in mind that although acceleration is in direction of change of velocity, it is not always direction of motion. When an object is slowed down, its acceleration opposite to the direction of its motion. This is known as deceleration. So you have started with 0, increase the speed and going with great speed. Suddenly, you need to stop. So what will do? You apply the brakes and stop. So from final velocity, again becomes the velocity decreases and becomes 0. Becomes 0. That is, what happened there? Velocity is decreased. After reaching the peak level, again decrease to 0. So that is called deceleration or negative acceleration, or it is also called as retardation. So decreasing of velocity. Increasing of velocity, you can call it as a acceleration. See, I'll take a simple example I'll give. Right. So, for example, you can see here. U is the initial velocity I told already, or V0, whatever it may be. Initial. V is the final. Right. And T is the time. In such case, A is equal to V minus U by T. There is acceleration. In case U is more than V. So in case of retardation, what happened? Initial velocity is more. Final velocity comes down to 0. That is, A is equal to U minus V by T will get. That is, we'll get the negative acceleration, minus V. The velocity is decreased from some velocity to came down to some velocity. So decreasing velocity is known as deceleration or retardation or negative acceleration, which is right. See here, misconcepts are of deceleration versus negative acceleration. So there are so many cases are given where is that acceleration or deceleration always refers to acceleration in the direction opposite to the direction of the velocity. As moves opposite only, velocity come down. Deceleration always reduces the speed. Negative acceleration, however, in acceleration is negative direction is chosen the coordinate system. Negative acceleration may or may not be acceleration, and deceleration may or may not be a considered as negative acceleration. Sometimes happen. This car is speeding up as it moves towards the right. It therefore has positive acceleration, right? This car is slowing down, slowing down. See, direction of acceleration is opposite, right? Towards the right. Therefore, it has negative acceleration in our coordinate system because its acceleration is towards the left. The car is also decelerating. The direction of acceleration opposite to the direction of motion called deceleration. Okay. Just common examples you can see. See, another one. Case 3, what is going there? See, this car is moving towards the left, but slowly down over it, down over the time. Therefore, its acceleration is opposite in our coordinate system. If x-axis is going like this, car is going in the opposite direction because it is towards the right. However, the car is decelerating because its acceleration is opposite to the motion. So motion is this direction, it is moving in this direction. This car is speeding up as it moves towards the left. It has negative acceleration because its acceleration towards left. However, because its acceleration is in the same direction as its motion, it's speeding up, not decelerating. So acceleration is a vector quantity. Its direction is same as that of change in velocity. Therefore, three possible ways by which velocity may occur, change may occur. Units are meter per second square or centimeter per second square. Because change in velocity, velocity by time. Velocity is given by meter per second, time again by second. So you get meter by second square or centimeter by second square. Unit for the acceleration. So acceleration is of two types. One is positive acceleration, other one is negative acceleration. Positive acceleration is nothing but increasing of time, increasing of velocity with time. And negative acceleration is nothing but decreasing of velocity with time. Okay. So either acceleration can be uniform or can be non-uniform. Already we have seen uniform is constant. Keep the velocity is changing constantly for every time. The body is said to have uniform acceleration. Its magnitude and direction of the acceleration remain constant during the motion. If a particle is moving the uniform acceleration, this does not necessarily imply that particle is moving the straight line. Example, projectile motion. Projectile means just like a football hitting the ground. Like this. We are hitting this motion. The path forward is called projectile. Mathematical word. Okay. Non-uniform. A body is said to have non-uniform acceleration if magnitude and direction are both changes during the motion. So when both are constant, we can call it as uniform. When both changes, you can call it as non-uniform motion. So these are all the terms which are related to our motion of a body. When a body is in motion, the body will have cover some distance, displacement, velocity, speed, acceleration, and retardation. Of course, time. Time is common everywhere. Time is nothing but the duration between two events. Right? Starting, ending. The duration is called time. So all these terms have some relationship among themselves. You can see directly some bits you can answer from here. Levels, any level you can say rate of change of velocity is nothing but acceleration. Right? So CGS unit of acceleration, centimeter per second square. You have to completely go read carefully and you can put the answer easily directly you can do. Right? Simple problem based on the velocity is equal to distance by displacement by time. Speed is equal to distance by time. Acceleration is equal to rate of change of velocity. Based on that, you can calculate either speed or time or velocity or acceleration. Anything you can calculate. Okay, clear? So these are the, so we finish what is motion, what is rest, types of motions, and terminology related to motion or terms related to motion. Okay, before going for the next topic, let me show you one video on the acceleration and retardation. Then we'll move to the
Have you ever watched Formula One? Many racers compete in a circuit to be the fastest to cross the finish line. Their maximum speed can reach 360 kilometers an hour, but right when they get across the finish line, their velocity is almost zero. How is that possible? We will do a little bit of a review. Speed. Speed, a scalar quantity, is determined by dividing the distance traveled by an object by the time elapsed. The international unit, or SI unit, for distance is meter, and for time is second. In reality, it is difficult to race at a constant speed for the entire duration of the race, so usually the average speed is calculated. For example, a Formula 1 circuit has a length of 4 kilometers, and the cars need to complete 72 laps to finish the race. The winner completes all of them within 2 hours. So the total distance of the car is equal to 288 kilometers, and the winner's average speed is 144 kilometers per hour. Converting the units into SI units, we can determine that its average speed is 40 meters per second. Velocity. Velocity, a vector quantity, is determined by dividing the total displacement by the time elapsed. For example, as the driver goes past the halfway point for the first time, the average velocity can be counted by measuring the length between it and the start line, divided by the time elapsed. But as the drivers return to the initial place where they cross the finish line, their displacement is nearly zero, because it is close to the same point as they start the race. Thus, their average velocity is also negligible compared to their average speed. We've made a simpler explanation on displacement and velocity, along with the introduction to scalar and vector quantities, somewhere in the channel. Now, back to the circuit. Before they race along the track, the car is at rest in the start line. When the red lights are turned off, do you think they just magically move at 200 kilometers per hour from rest? Of course not. In physics, there is a certain term called acceleration. What actually happens is, when he sees the red lights turned off, the driver will push on his accelerator. His car will gradually move faster until it reaches a certain velocity. A body is said to be in acceleration if its velocity is changing. As the velocity is a vector quantity, the change can be in the magnitude or in the direction of the movement. Thus, we can say acceleration is the rate of change of velocity. If the velocity is increasing, we call it acceleration. When the velocity is decreasing, we call it deceleration or retardation. The standard unit for acceleration is the unit of velocity divided by the unit of time, which becomes meter per second squared. The acceleration can be better understood with the following example. If a car starts from rest and reaches a velocity of 72 kilometers per hour in just 4 seconds, its acceleration can be counted as the initial velocity is 0 since the car starts from rest. The final velocity is 20 meters per second, and the time elapsed is 4 seconds. Acceleration is then equal to 20 divided by 4, which is equal to 5 meters per second square. If the car is indeed increasing its velocity by 18 kilometers per hour each second, the car undergoes uniform acceleration. But if the car has different changes of velocity each second, for example, a higher increase due to the downhill or slowing due to the speed bump, it is called non-uniform acceleration.
Right. So everything is clearly explained. What is acceleration, what is uniform acceleration, and what is non-uniform acceleration. Right? Clear. Now, we'll come to the next part. That is very, very important in physics. That is equations of motion. Equations of motion is nothing but when a body is in motion, we'll come across so many terms like u, v, acceleration, time, displacement. All these we learned, right? What is initial velocity, what is final velocity, what is acceleration, what is time, and what is distance or displacement. The relationship among these, all these 5 quantities are not independent. They are having some relation among themselves. Thus, relationship gives the equations of motion. There are Three equations of motions are there. Equations of motion. Four are there, of course. The first one, V is equal to U plus AT. That I will tell you. The second one, S is equal to UT plus 1 by 2 AT square. Third one, V square minus U square is equal to 2AS. You note down these four equations. And fourth one, Sn is equal to U plus A into N minus 1 by 2. Right? They are called equations of motion. Heading you write as a equations of motion. And first one is this. Second, third, fourth. V is equal to U plus AT. I will tell the derivations. Is there? The second one is S is equal to UT, U into T plus 1 by 2 AT square. Third one is V square minus U square is equal to 2AS. And last one is Sn is equal to U plus A into N minus 1 by 2. Or you can write Un also here. Un plus A into N minus half. Write down these four equations which are popularly known as equations of motion. If you know this, you can do some 50% of physics problems from these equations only. Not only in kinematics or Newton's laws, these formulas can be used in any chapter of physics. Heat, you have to use these formulas, and wherever you go, every chapter, make use of these particular equations to find the distance, displacement, velocity, time, acceleration. So this equation plays very important, which is given by the Sir Isaac Newton. First two three are common for everyone. Fourth one is little, will come across in the higher classes, maybe 9th, 10th class. So equations of motion, number one, V is equal to U plus AT. Second one, S is equal to UT plus 1 by 2 or half AT square. Third one, V square minus U square is equal to 2AS. And fourth one, Sn is equal to Un plus A into N minus 1 by 2. So I'll explain each and every term and also how to get these equations. Right? Hope you are done. Okay. So when you come to the first part, first one, first equation you can see here, first equation of motion, right? So relation between velocity and time. Velocity time relation. So first equation I already wrote, V is equal to U plus AT. How you got it? From the definition of acceleration. Acceleration is nothing but change in velocity by time. So that is final velocity minus initial velocity by time. That is A is equal to V minus U by T. Right? Take T this side. It becomes V minus U is equal to AT. Take minus U that side. So V is equal to U plus AT or AT plus U. That's all. So equation 1 can be derived from velocity time relation, that is velocity by time, which is nothing but acceleration. From the definition of acceleration, we can get V is equal to U plus AT, where V is equal to final velocity, U is equal to initial velocity, A is equal to acceleration, and T is equal to time taken. Clear? This complete derivation for the first equation of motion, which is the relationship between velocity and time. Now, when you come to the second one, right, equation number 2, that is displacement time relation. The equation already given here. So how to get that equation? You can write it. As there are two velocities are there, initial and final, we have to find average velocity. Average is nothing but v plus u by 2. So there are two velocities, initial velocity, final velocity. So we have taken average. Right. So we know displacement is equal to average velocity into time. We know displacement is equal to velocity into time, because velocity is equal to distance by time. So what is velocity? Average velocity. In place of velocity, you take average velocity into time. Right. Average velocity into time you have taken up to here. Okay. Clear? So from this, from first equation, v is equal to u plus at. In place of v, this v you can take u plus at. Means we are substituting first equation in place of v here. So u plus, in place of v, you can write u plus at by 2 into t. S is equal to. So u plus u, 2u. We'll get 2u by 2u plus at into t by 2. So from that we got the S is equal to ut plus half at square. It's very simple. This is displacement and time. So you know velocity is equal to displacement by time. So displacement is equal to velocity into time. So velocity we have taken the average, because there are two velocities are there. We have taken average of that, average velocity in place of v. Again in place of v, we substitute the equation 1, u plus at. Then both two substitutions we have made. And finally we got S is equal to ut plus half at square. Equation number 2. Simple way. By using the distance is equal to velocity into displacement is equal to velocity into time. But in place of velocity, you have taken average velocity into time t. But in place of v, we substituted u plus at again. V is equal to u plus at. After calculations, 2u by 2, at square by 2, we can write 2 will cancel here. So finally, we get S is equal to ut plus half at square. S is the displacement, u is the initial velocity, t is the time taken, and a is the acceleration. Okay? Clear? Right. So one come to the third equation. Is a combination of 1 and 2 we can do. Combination of 1 and 2, which is velocity displacement relation. What? Velocity displacement relation. Third one. So same average velocity are taken, same like previous, v minus u by 2. Also displacement is equal to average velocity in time. We got this. S is equal to u, same like second equation. And from first equation also we have done. From v is equal to u plus at, we wrote v minus u is equal to. See, v is equal to u plus at. Right. So from here, what is t? In place of t, t is nothing but v minus u by a, substituted here. In place of this t, we substituted from this formula, v is equal to u plus at. Bring u this side. V minus u is equal to at. So t is equal to v minus u by t, movement by a. So in place of t, we substituted v minus u by a. Right? So v plus u plus v by 2 into v minus u by a. Very interesting. So v square minus u square by 2a. That is equal to v square minus u square is equal to 2a. Yes, simple. We use the second equation and first equation to get the third equation. Equation 3. Clear? So from first equation we have taken t value. T is equal to v minus u by a. From second equation we taken S is equal to average velocity into time. In place of the time, we substituted v minus u by a. As in anyway, average velocity is there. Then you can use the formula a plus b into a minus b is equal to a square minus b square. So u plus v into v minus u minus v is equal to v square minus u square is equal to 2as. That is the third equation of motion. Clear? So fourth one also there here. This we'll discuss next. The derivation. This is for a particular time, particular period of time. For example, see, a body. started from here, right? Started from here and moves up to here in 5 seconds. 5 seconds body covers 10 meters. Example I am telling. What is the distance traveled by body? For example, first second, second second, third second, fourth and fifth second. So this is total 5 seconds for entire this. So what is the distance traveled in fifth second? Fifth. What is fifth?